Good evening. This month's programme is all about the craters of the moon. As a youngster, just about everyone has gazed up at the moon and watched it change its daily appearance, while even binoculars are enough to show the main seas and lunar craters on view. I received many emails and Facebook messages from viewers asking about the craters of the moon, the best time to observe them, and the best telescope to use. Therefore, in this month's programme, I thought it would be useful to give a general guide. I have chosen some of the largest craters that are visible in binoculars or even with the unaided eye, under good seeing conditions. Hopefully, it will inspire you to become a lunar observer and go out to take some fine images of the moon. The moon is the Earth's natural satellite that orbits around our planet once every 27 days, and we are fortunate that on average it is only 386,000 kilometres distant, which allows its surface features to be seen clearly in small-sized telescopes, even binoculars. The moon is 3,480 kilometres in diameter and shows a series of phases from new moon, then first quarter, full, last quarter and back to new moon, which it completes once every 29 days, 12 hours and 44 minutes. This is known as the moon's synodic period and is often referred to as the lunation by astronomers. Each new lunation is measured in days from new moon, so first quarter sees the moon aged 7 days old, full moon occurs at 14 days, and last quarter is the moon aged 22 days. For many of us, the moon is the first port of call when setting up for a night's observing session, if only to scan the lunar landscape to try out the field of view of various eyepieces. While for the deep sky observer and commentary photographers, it is perhaps their least favourite because the moon hides faint objects in the night sky. There are two important points to be made. Firstly, there is a lot of useful work that the amateur astronomer can do, so I recommend that you join your local astronomical society and attend their meetings and observing nights. Here you will meet experienced amateurs who will be pleased to answer your questions and show you the moon through modest-sized telescopes. It is also nice to discuss your own observations with others and to share your images of the moon and its surface features.
I'm Bill Leatherbarrow, Director of the Lunar Section. The moon's probably the object that most people look at first when they look at the night sky. It's usually available, it's usually visible, it's easy to find, it shows a remarkable amount of detail for any size of telescope, no matter how small or large. It's very dramatic, the constant play of shadow and light over the surface, it's always changing, and it generally gives people a lot of pleasure. Now, if you're interested in simply looking at the moon, we'd welcome you in the lunar section. There's plenty of space for people like yourselves who just like to watch the play of light and shade over the moon's surface. But the moon's also interesting in other ways. There's still, despite spacecraft, despite close-up photography, there's still a lot of work that the amateur can do, and we would welcome anyone into the lunar section who's interested in taking part in that kind of work. The work can be either visual, if you simply use your eye at the telescope, plenty of things that you can do, plenty of programs that you can follow where the observations are organised and they lead to a proper, interesting outcome. If you're interested in digital lunar photography, the opportunities are almost endless these days. With modern webcam technology, you can take photographs of the lunar surface that show an enormous amount of detail. And again, there are programs available within the lunar section that are directed to various ends. There's something for everybody. I'm sure you'll find it interesting. If you'd like to join, do get in touch with me.
Secondly, do invest in a map of the moon. They are inexpensive and it will allow you to find the many craters and surface features on view. Here is a link to the British Astronomical Association Lunar Map by Peter Grego. Do bear in mind that an astronomical telescope turns the image of the moon upside down, so that south is at the top and the eastern limb appears on the left side of the moon. Here are some nice examples of lunar maps. This is an outline map of the moon by Sir Patrick Moore, drawn by Patricia Cullen in 1969, which is drawn with the Lunar Observer in mind. The second is the moon map by George Phillips, which is available from good bookshops. It shows the moon right side up with lots of named craters, surface features and the seas. This third map is by the US Geological Survey and comes in various orientations and again shows lots of detail. Finally, this map is available from the National Geographical Society and it shows both the near and far sides of the moon. I am most grateful to award-winning photographers David Blanchflower, Damien Peach and Alistair Woodward for allowing me to use some of their splendid images in this month's programme. David lives in Newcastle upon Tyne and uses a Skywatcher 200p telescope. Damien lives in Chelsea and his main instrument of choice is a 30cm Meade-Smith telescope. The Earth is the third planet out from the Sun, and like the other main planets in our solar system, has an inclination of less than 3 degrees, which means that along with the Sun, they follow the same path among the constellations, known as the ecliptic, which passes through the 12 zodiacal constellations. Both Mercury and Pluto are the exceptions. Mercury is inclined by 7 degrees and Pluto 17. The Moon orbits around the Earth and is inclined to the plane of the Earth's orbit by about 5 degrees, which means that it can be seen up to 5 degrees above or below the ecliptic in the sky. The Moon's path along the ecliptic takes it through the zodiac, and due to the closeness to the Earth, the Moon covers the distance of its own apparent diameter once every hour, which adds up to about 13 degrees each day. The 4 seasons are due to the Earth's polar axis being tilted by 23.5 degrees to the plane of its orbit around the Sun. In the Northern Hemisphere, it is summer from the 21st of June, when the North Pole is tilted towards the Sun, and winter begins on the 22nd of December as the North Pole is tilted away from the Sun. Therefore, in the Northern Hemisphere, the best time to observe the Moon is during the winter period, when the ecliptic is at an high elevation. The worst time is during the summer, when the Moon is low down in the sky because the ecliptic is at a low elevation. For observers in the Southern Hemisphere, the opposite is true. The Moon travels around the Earth once every 29 days and 12 hours, and during a typical month, one day after new moon, it first becomes visible low in the eastern sky at dawn. As the days pass, the Moon becomes increasingly prominent as it waxes towards full moon and is visible during the daytime. The length of time that the Moon is visible in the daytime sky depends on the time of year. During the early hours of the morning, it wanes through last quarter, and the Moon is eventually last seen as a slender crescent in the western sky just before sunset, when it is said to be 28 days old. To observe the Moon, all you really need is a pair of 10 by 50 binoculars, which will show you all of the dark areas known as Maria, along with some of the largest craters, while a small telescope is enough to show hundreds more craters along with some finer detail. As I have said, such a telescope will actually give you an upside-down view, which is not satisfactory for normal purposes, and so an extra lens system is incorporated inside the tube to make everything erect. This is left out from an astronomical telescope because here light is all important, as we need all we can gain to view faint objects like nebulae and galaxies. When a light beam passes through a lens, it is slightly weakened. Therefore, all astronomical telescopes give an upside-down view with the south uppermost and the eastern limb of the moon on the left. In order to do useful work, you will need either a 75mm, that's a 3-inch refractor, or a 150mm, that's a 6-inch reflector telescope, which are ideal. In this month's programme, I will be using normal binocular views of the moon, and all times are given in UT, known as Universal Time, which is the best arrangement since our programme is seen by a worldwide audience. As viewed with the unaided eye, we see the dark lunar plains known as maria or seas. Of course, there are no oceans of water on the moon. These maria are actually dark volcanic lava fields.
From year to year, the moon never seems to change. Craters and other formations appear to be permanent now, but the moon didn't always look like this. Thanks to NASA's Lunar Reconnaissance Orbiter, we now have a better look at some of the moon's history. The moon likely started its life as a giant ball of magma formed from the remains of an impact on Earth about 4.5 billion years ago. After the hot material collected into a sphere, the magma began to cool, eventually forming a crust on the surface of the moon with the magma just underneath. Around 4.3 billion years ago, a giant impact battered the moon's south pole, forming the South Pole Aitken Basin and sending debris as far as the opposite side of the moon. This impact marked the beginning of a period that would cause large-scale changes to the moon's surface. One by one, more huge collisions shaped the terrain, some forming large basins that would eventually fill in to become the dark-colored patches of the moon, known as maria. They began as normal craters, but soon started to change due to the size of the impact on the relatively thin crust. Because the moon had not yet fully cooled on the inside, lava began to seep out through the cracks caused by the impacts. The resulting volcanic activity spread lava throughout the craters, gradually filling them in and cooling. Because of the high iron content of the basalt in the rock, the maria reflect less light and therefore appear darker than the surrounding highlands of the moon. Around 1 billion years ago, volcanic activity ended on the near side of the moon as the last of the large impacts made their mark on the surface. The moon continued to be battered by other impactors, although they were much smaller than the objects that formed the largest basins. Some of the largest, most recent, and best-known impacts from this period include the Tycho, Copernicus, and Aristarchus craters, which are unique due to the complex system of rays that stretch out from the impact site. Finally, we arrive at the moon that we see today. Though the surface continues to be affected by impacts, the rate has slowed down drastically to the point where the moon appears unchanging to the human eye, as a permanent record of its own history, and a glimpse of how craters may have formed here on Earth.
Let us begin by learning to find the lunar seas. There are 12 maria on the Earth-facing side of the moon, the largest being the Oceanus Procellarum, Ocean of Storms, on the western hemisphere, with the Mare Imbrium, Sea of Showers above, and Mare Nubium, Sea of Clouds below, near to the southern lunar highlands. On the eastern hemisphere of the moon, we see an upside-down Y feature, made up of 4 dark seas: the Mare Serenitatis, Sea of Serenity; the Mare Tranquillitatis, Sea of Tranquility; the Mare Fecunditatis, Sea of Fertility, which forms the right prong of the Y, and the Mare Nectaris, Sea of Nectar, forms the left. The Mare Crasium, Eastern Sea, is easily visible close to the upper right quadrant of the moon. The Mare Frigoris, Sea of Cold, is visible across the upper part of the moon's disk, just below the moon's northern highlands, which make up the northern polar region. The central area of the moon is dominated by the lunar Apennine mountain range, which was the landing site for Apollo 15. There are 3 lunar seas here: the Mare Vaporum, Sea of Vapours, the Sinus Astium, Bay of Billows, and the Sinus Medi, Central Bay. The Mare Humorum, Sea of Moisture, can be seen on the lower left of the Moon. By learning to recognize these prominent lunar seas, you will be on your way to identifying the main craters of the Moon, which you will find rewarding. Following the sequence of the Moon's phases and taking New Moon as our starting point, let us begin with the 3-day-old Moon, which is the first occasion features on the Moon become visible. In the Northern Hemisphere, the crescent moon rises in the eastern sky at about 7 a.m. and then sets in the west at about 11 p.m. This is a photograph of the 3-day-old Moon taken by David Blanchflower. The large area upper right is the Mare Crisium, or Eastern Sea, which is well defined. Moving down along the eastern terminator, you come to 4 large craters, the first of which is Langrenus. This crater is 133 kilometers in diameter and has a central peak 1,000 meters in height. The next is Vendelinus, which is slightly larger than Lagranus, irregular in shape, and measures 147 kilometers in size. It has a large flat floor containing many small craters that are nice to observe. Moving along, we then come to the 177 kilometer crater Petavius, with Furnarius next in line. Here are photographs showing the craters themselves. The Mare Crisium is 500 kilometers in diameter and covers an area of 200,000 square kilometers and is one of the most recognizable features on the Moon. The terminator, the dividing line between night and day, runs through the Mare Crisium this night, making the lunar landscape stand out, showing a lot of detail. Of course, there are occasions when the Moon's limb turns a little towards the observer and Mare Crisium is fully on view. These are called librations and are rewarding times for the Moon observer. Information about these librations can be found in the Astronomical Ephemeris or the Handbook of the British Astronomical Association. On the Mare Crisium are 3 craters of reasonable size: Picard, Pierce and Pierce A, all visible in small telescopes. Also notice the big 126 kilometer crater Cleomedes directly above Mare Crisium, which is very prominent. Looking at the Moon with a small telescope, the lunar limb is a busy place with many smaller craters on view, and as the Moon's phase waxes and grows towards first quarter during the next 5 nights, there is an air of excitement. In the Northern Hemisphere, the first quarter Moon rises in the eastern sky about midday, transits due south at 6 p.m. and goes on to set below the western horizon about 30 minutes after midnight. Here is a photo of the 7-day-old Moon. The whole of the eastern hemisphere is now nicely on view, but contains the nice inverted Y-shaped feature made up of the 4 maria or seas: the Mare Serenitatis, Sea of Serenity, the Mare Tranquillitatis, Sea of Tranquility, making up the 2 large areas west of the Mare Crisium. Below this, the Mare Fecunditatis, Sea of Fertility, marks the eastern prong of the Y, and Mare Nectaris, Sea of Nectar, the western. Again, here are some nice images of the Moon. Right at the top of the Moon's disk, the dark area sweeping in from the west is part of the Mare Frigoris, Sea of Cold. There are now more large craters on view to tempt the lunar observer. Langrenus, Vendelinus and Petavius can still be seen. On the lower eastern portion of the Moon's disk, the craters run in a line below the Mare Fecunditatis. They are quite easy to find and they make a nice photo opportunity. Another nice group are the craters Theophilus, Cyrillus and Capharina. Located a little below the centre of the Moon's disk, near the Mare Humorum. Theophilus is a crater 100 kilometers in diameter, containing a large central peak 1,400 meters high. Cyrillus is a similar size with high walls and has an extensive floor with 3 central mountains and a groove to the south. Capharina is a damaged circular crater with steep slopes and small craters on its floor. On the southern edge of the Mare Humorum is the large 124 kilometer crater Pracastatorius, which is easy to find. I have seen it many times, and this crater is a favourite of mine since there is much to see on the lunar landscape in the Mare Humorum area, making this an ideal photo opportunity. Next, look for the 2 large craters, Sacrobosco and Maurolycus, on the Moon's terminator. They cannot be mistaken, as they are so prominent at this time. Maurolycus is the larger of the 2. It has a diameter of 114 kilometers and has many smaller craters on its floor. The southern highland region of the Moon is dominated by craters. There are many to choose from. Pitiscus, Hummel, Mutus and Menzinus are probably the best. A good map of the Moon will allow you to identify most of them. Over the next 7 days, the Moon's phase waxes towards full moon, which is an exciting time for lunar observers, as there is much to see as the terminator sweeps across the lunar landscape. In the northern hemisphere, the 10-day-old gibbous moon rises in the east about 2:20 p.m. and is visible throughout most of the daytime. Here is another nice photograph from David showing the gibbous moon. In the northern hemisphere, it transits due south at 8:30 p.m. before going on to set below the western horizon at about 1:30 a.m. the following morning. The Mare Imbrium, Sea of Showers, is now coming nicely into view, upper left, with the Montes Apenninus mountain range which borders the Mare Serenitatis, middle right. For observers in the northern hemisphere, both these seas mark the eyes of the man in the moon. The Mare Nubium, the Sea of Clouds, lies at the bottom left-hand edge of the moon. Even with the unaided eye, you will be able to make out the bright rayed crater Tycho in the moon's southern highlands, despite it being only 86 kilometers in diameter. Here are some nice photographs of the moon showing Tycho well. It has a very steep and tormented slopes and has a relatively flat floor with a central peak rising up 1,500 meters. Nearby on the terminator are the large craters William and Longomontanus, and the large spectacular crater Clavius lies directly below Tycho. The region makes an ideal photo opportunity since there are many splendid craters to choose from. There are also 3 large craters on view, but are perhaps the most celebrated by lunar observers. Copernicus on the Moon's upper western terminator, with Eratosthenes to its right, and Archimedes next to the Montes Apenninus mountain range. Copernicus is a crater 93 kilometers in diameter, with a large flat floor and high walls, and is always a nice sight in small telescopes. Eratosthenes is only 60 kilometers in diameter, and again has a flat floor with high walls, although it does have a central peak which is visible under good seeing conditions. Archimedes is 83 kilometers in diameter, which has a dark floor and no central peak. All of these craters are quite spectacular in their own way and make ideal photo opportunities, as we see here. Also look out for the large dark floor crater Plato on the northern edge of the Mare Imbrium. It is 109 kilometers in diameter, quite prominent and easily recognizable as it sits comfortably within the Montes Alpinus mountain range. The large area directly above Plato is Mare Frigoris, Sea of Cold, which is quite prominent during the Moon's gibbous phase. The Mare Serenitatis is the top of the inverted Y feature on the upper left of the Moon's disk. I would like you to notice the two craters Menelaus and Plinius. Plinius is actually not all that big. It is only 43 kilometers in diameter and has a large flat floor with high slopes, while Menelaus is smaller still, being only 26 kilometers in diameter and has a central mountain. As the Moon's phase increases towards full moon, this is a good time to observe lunar features, especially around the southern polar regions of the lunar highlands. Full moon is actually the worst time to study the Moon because from the Moon's point of view, the Sun is high overhead and its brilliance drowns out the surface features. We now need to wait until the Moon's phase is on the wane and the terminator begins to sweep across the Moon's landscape from the western limb. In the northern hemisphere, the full moon can be seen rising above the eastern horizon just before 10 p.m. and sets in the southwestern sky at about 4 a.m. just before sunrise. Here again is a nice photograph of the 14-day-old moon taken by David Blanchflower. All of the lunar seas are prominently on view, along with all the large craters I have just described. The large dark plain covering much of the Moon's western hemisphere is the Oceanus Procellarum, Ocean of Storms, with the Mare Imbrium above and to the west. Oceanus Procellarum is the largest of the dark lunar plains on the Moon's surface. It measures 2,568 kilometers wide. The most prominent crater is Aristarchus, which, like Copernicus, has a system of bright rays. Aristarchus is 40 kilometers in diameter and lies above the Moon's equator, some distance to the left of Copernicus. A telescope will show the magnificent rail feature that meanders from the crater. Once again, this makes for an ideal photo opportunity. 3 days after full moon, we are back to a gibbous phase. In the northern hemisphere, the moon, aged 18.5 days, rises in the southeastern sky at about 10 p.m. and transits due south at 2 a.m. and then goes on to set in the west at about 6:30 a.m. so it is visible throughout the night. Notice the prominent dark floor crater named Grimaldi on the Moon's western limb. This is one of the largest craters on the Moon, measuring 172 kilometers in diameter. It is easily visible to the unaided eye, while a pair of binoculars will show it nicely. The magnificent raid crater, Tycho, is still on prominent display on the southern highlands, with the terminator bringing into view a number of large prominent craters on the lower eastern limb. Here are some nice photographs of the craters. Maurolycus is there, along with Fabricus and Jensen. There is also a trio of craters nearby, two of which I mentioned previously, Pitiscus, Hummel, and the third is named Vlach. The Moon continues to wane during the next few days until we arrive at the last quarter, when only the western hemisphere is on view. This is another nice image of the Moon, aged 22 days, from David. The Moon rises in the eastern sky about midnight, then sets about 11:30 a.m. in the western sky after being on view in the daytime sky. Grimaldi is still nicely on view on the Moon's western limb, with the crater Riccioli close by. I would like you to notice the prominent white feature directly below Grimaldi. This is the crater Kruger. This is another ideal time to observe the craters Tycho, Magnius and Clavius, which now lie near the lower eastern limb of the Moon. Here again are some photographs showing the landscape. This is another ideal time to observe the craters Tycho, Magnius and Clavius, which now lie near the lower eastern limb of the Moon. There is one lunar feature worth searching for, which is known to astronomers as the Straight Wall, or Rupes Rector, which is a huge fault crossing a ghost crater. The wall is 110 kilometers long and casts a wide shadow. Despite this, it is really not very high, ranging 240 to 300 meters in height. Heights of objects close to the terminator are often exaggerated by the glancing rays of the sun. Although the slope of this fault line looks steep, it is really quite gentle compared to similar fault lines here on Earth, only about 7 degrees. A cluster of hills at the southern end of the straight wall often looks like the handle of a sword, the blade being formed by the straight wall itself. As the moon continues to wane, its phase becomes a crescent in the sky, and the terminator passes across the crater Schickard 3 days before new moon. Schickard is a great wall-plain crater, 200 kilometers in diameter. At this stage, in the northern hemisphere, the moon rises at about 2 a.m. and sets in the western sky at about 4:45 p.m. after spending time in the daytime sky. We now arrive back at new moon, and the sequence of phases will repeat themselves. The moon is always a splendid sight in the night sky, and learning to find the seas and large craters on its surface is always very rewarding. On the next clear night, do go outdoors and see how many of the moon's craters you can identify, along with the main lunar seas, and with a little practice you will be able to find your way around the moon's disk easily enough. That is all we have time for this month. If you are interested in photographing the moon, I recommend Amateur Astrophotography magazine. Please visit the website at amateurastrophotography.net. Also, please visit our own website, Vimeo, where you can watch all the past shows of astronomy and space. Here you will find my program Observing the Moon, which was broadcast on the 1st of June 2014. It shows the different methods of observing the moon for the amateur astronomer. If you like this program, please share it with your friends and members of your local astronomical society. Until we come back next month, good evening.